Next topic is internal energy, heat and work. Starting with the internal energy. For a system which is filled of gases, which is filled of number of gases in it, the internal energy is actually the energy of the system. Internal energy means energy of the system. It has nothing to do with the surrounding, as this is a system. The other outside is surrounding. As it have nothing to do with the surroundings, so the energy of this system, that is called internal energy. Where internal energy is the sum of kinetic and potential energy. Internal energy it is the sum of potential energy and kinetic energy. But in thermodynamics, as we are deal with the macroscopic system of the gases, for gases they always keep on moving. They are always in motion. It means the potential energy for the gases is almost zero, or we can say that internal energy entirely depends only on the kinetic energy of the gases. So more the kinetic energy, more is the internal energy. Less the kinetic energy, less is the internal energy. Where kinetic energy, we have a formula of 3 by 2 K T, where T is temperature. So kinetic energy depends on temperature. More the temperature, more the kinetic energy. Or we can say indirectly, internal energy depends upon internal energy depends upon temperature. It is denoted with the symbol of U. This is symbol of internal energy. So, as temperature increases, internal energy of the system also increases. As temperature decreases, internal energy decreases. So, delta U represent change in internal energy. Change in internal energy. If the change is quite small, then we replace this delta with D. So du represent also change in energy, a small change in energy. So next is heat. Heat is actually what? It actually energy which flow from a system at high temperature to a system at low temperature, where the flow of heat is mainly due to the difference of temperature. If the difference of temperature is not there, there will be no flow of heat. So it is just due to the difference of temperature. So heat is represented by a symbol of Q. If heat is given to the system, then it is taken as positive because it increases. Q is taken as positive. If it is given by the system to surrounding, then Q is taken as negative, and change is represented by D or delta. So as heat depend upon the different mode, like due to conduction, convection, radiation, these all are various methods for the heat transformation. So it depends upon the path followed, not on the initial and the final condition. So it is not a state variable. It is not a state variable. Next topic is work done. Work done. Here work is done by the gas. If I have a system fixed with a piston, movable piston it is, this is the gas inside the system. If gas molecule expand, they will push the piston in upward direction and volume increases. Volume will increase. Change in volume will be positive. Change in volume will be positive. So work done, we have a formula for the work done, that delta W is equals to P delta V. So volume increases, so delta V also increases. As a result, work done also increases. To delta W is positive. So this is what? This is the work done by the system. Work done by the system, and it's taken as positive because here volume increases. In chemistry you do, but you take opposite sign of this. So if piston is compressed by the outer agent, in that case volume will decreases. If volume will decreases, then work done, then this decreases, so work done also decreases, so it is negative. So it means work is done on the system by surrounding, so it is taken as negative. So work done also depend upon the path followed, so it is also not a state variable, it is also order state variable. Is it clear?